Well, good evening, folks. Hopefully you're all doing well. This is Mike coming back at you with another video on precalculus. In the previous video, we talked about verifying trig identities using all of our lovely trig properties to verify some identities that seem kind of pointless or we're not sure where we're going to use them ever, but also some that are very important and that can be quite handy. In this video, I want to talk about the sum and difference formulas for sine, cosine, and tangent. What these sum and difference formulas allow us to do is they allow us to find the values of the sine, cosine, and tangent functions, as well as secant, cosecant, and cotangent functions at seemingly uglier angles, but these seemingly uglier angles can actually just be represented as the difference or sum of two nicer angles that we already know values of those trig functions at. So let's get right into the sum and difference formulas for sine and cosine to start with. If you have two angles, alpha and beta, the sine of alpha plus or minus beta is equal to sine of alpha times cosine of beta plus or minus cosine of alpha times the sine of beta. Now just a quick bit of notational clarity here. I've incorporated both the sum and difference formulas all in one statement here. Same thing for cosine when we get there. If you're taking the sum here, you're obviously going to use the plus sign that's on top. You're then going to use the sign that's on the top here. If you're taking the difference, you'd obviously be using the minus, which is on the bottom. That means you're going to be using the minus sign here. So sine of the sum or difference, you're then using the corresponding sum or a difference on the right-hand side. Top sign goes with top sign, bottom sign goes with bottom sign here. For cosine of alpha plus or minus beta, it's not plus minus over here, it's actually switched. So for cosine, if you're doing the sum of angles over here, in the right-hand side, you're going to be using a minus sign. And if you're taking the difference of two angles here on the left, you're going to be putting a plus sign in the middle here on the right-hand side. For the cosine, it's cosine of alpha times cosine of beta minus or plus sine of alpha times the sine of beta. So just a couple examples of some seemingly uglier angles that we can now find the values of sine and cosine and even tangent at. 15, I can represent 15 as the difference of 60 and 45, or of 45 and 30. 5 pi over 12, that's an angle that's in radians. If you convert it to degrees, it would be 75. And you can represent that as 30 plus 45, or pi over 6 plus pi over 4. So these seemingly bad angles we can now actually do something with. So let's do a couple sample problems here so far, just to at least help us see how these formulas would be used. We're going to start off with finding the sine of 105. So I'm thinking, what two angles can I take the difference or sum of to get 105? And the idea is you want to use some relatively nice angles here. And by nice, I mean those common angles that we know values of our trig functions at. Well, 105, if you think about it, is 60 plus 45. And 60 and 45 are two nice angles that we have. We can easily recall or easily find, worst case, the values of sine at 60 and at 45 as well on their own. Same thing with cosine. Cosine of 60 and cosine of 45, and we can make those substitutions in this formula. So here, my alpha is 60, my beta is 45. I'm taking the sum here, which means that in the formula here at top, we're taking the plus on the left-hand side. That means we're going to be taking the sum on the right-hand side as well. So this is going to equal the sine of 60 times the sine of 45. My apologies, cosine of 45 plus the cosine of 60 times the sine of 45. So now we just have to recall what are the values of our trig functions at 60 and 45. Sine of 60 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Cosine of 60 is 1/2. And sine of 45 is radical 2 over 2. And radical 3 times radical 2 is radical 6. Radical 2 times 1 is radical 2. And those are both over 4, so I can write my answer as such. Radical 6 plus radical 2, all divided by 4. Let's go on to another sample here. The cosine of negative 15. Again, we want to think, what two relatively nice angles can we work with here and take the appropriate difference or sum of so that I get a negative 15. And probably didn't take you too long to think, okay, 30 minus 45 as one possibility here. You also could have done 45 minus 60. It would still get you the same thing in the end. So this is my alpha, 30. 45 is my beta. Now looking at the formula for the difference in cosine, the minus here is on the bottom. So we're using the symbol that's on the bottom on the right-hand side. And what's on the bottom is a plus. So plus is being used here, not minus. That's a key difference you have to keep in mind between the formulas using sine and the formulas using cosine. So this is going to be cosine of 30 times the cosine of 45 plus sine of 30 times the sine of 45. Cosine of 30, radical 3 over 2, cosine of 45, radical 2 over 2, plus sine of 30 is 1/2, and sine of 45 is radical 2 over 2. And it just so happens that we get the exact same answer as we did from our first problem. Radical 6 plus radical 2, all divided by 4. So guys, these are very basic, very straightforward formulas here for sine and cosine. The only thing you have to keep in mind is what sign you use on the right-hand side based on what sign you're using on that left-hand side. Think, for sine, if you're adding on the left, you're adding on the right. If you're subtracting on the left, you're subtracting on the right. You're doing the same thing for sine. If you are doing cosine, whatever sign you have on the left, you're switching it for that right-hand side. Here are the difference in sum formulas for tangent. Tangent of alpha plus or minus beta equals tangent of alpha plus or minus tangent of beta, all divided by 1 minus or plus tan of alpha times tan of beta. So, very important to note what sign you're using where. If you're doing the sum formula for tangent, on the top you're going to use plus, on the bottom you're going to use minus. If you're doing the difference formula, on the top you're going to use minus, on the bottom you're going to use plus. So, very important to keep those things straight because otherwise that can impact your final answer. So let's see a sample problem here where we use one of the sum or difference formulas for tangent. So we have the tangent of 5 pi over 12. Earlier on in the video, we said that if you converted 5 pi over 12 into degrees, you get 75. And thinking of two nice angles that will add or subtract out to 75, pretty straightforward to find that you get 30 plus 45. So I'm doing the sum of angles here, which means that I'm going to use a plus on the top, because that's the symbol on top here. Plus on the top, and then the symbol that's on the top for the bottom of our fraction here is the minus. So on the top of my fraction, I'm using plus. In the bottom of my fraction, I'm using minus. So this is going to equal tan of 30 plus the tangent of 45, all divided by 1 minus tan 30 times tan of 45. Now, the tangent of 30, if you'll recall, is 1 over the square root of 3. Tangent of 45 is 1. And then 1 minus 1 over the square root of 3 times 1, or 1 over the square root of 3. And technically this is the correct answer, but we have radicals in the bottoms of some of our fractions here. So if we were to rationalize this, multiplying it on the top and bottom by the square root of 3, you get 1 plus the square root of 3 divided by the square root of 3 minus 1. So that would be our final answer in this case. Technically, you could rationalize it more. The online software may be picky and they may want you to rationalize further, but this is one form of the correct answer. So I just want to show you one last problem. This is involving one of our other trig functions, cosecant, secant, cotangent. I chose secant here, and we want to find the secant of minus 75. Well, let's use some of our basic trig properties. We know that secant x is 1 over cosine x. So secant of minus 75 is going to be 1 over the cosine of minus 75. And now I'm going to pull a clever little trick to make this a lot easier. At this point, you may be thinking, okay, what are two kind of nice angles that will subtract out to negative 75? And you're going to be thinking for a little while as to what those two angles are. But think back several videos. We said that the cosine function was even. And that means, recall that when a function is even, it means that f of minus x is equal to f of x. So here I have minus 75 plugged into my cosine function. Since cosine is even, that means this is equal to 1 over the cosine of positive 75. And that is going to make things a lot nicer and a lot simpler to work with. It's not going to take much now to figure out what two angles we can combine to get 75. That's going to be 30 and 45, and big shocker, we're going to add them. Dun, dun, dun. So let's use the sum formula for cosine. Here we're using the plus, which is the top symbol on the left. So we're going to use the top symbol on the right, which is actually a minus now. And this means that we are going to have 1 over cosine of 30 times the cosine of 45 minus the sine of 30 times the sine of 45. Moving that up so we can all clearly see that. This was our sum formula for cosine here, substituting in the angles of 30 and 45. Cosine of 30, radical 3 over 2. Cosine of 45, radical 2 over 2. Now we're doing minus. Sine of 30 is 1/2. And then sine of 45 is radical 2 over 2. This gives me 1 over radical 6 minus radical 2, all divided by 4. And dividing by a fraction is the same thing as multiplying by its reciprocal. So that's going to equal 4 over radical 6 minus radical 2. Now, once more, technically we have radicals in the bottom of our fraction, so you could rationalize this more. You could multiply the top and bottom by the conjugate, but I'll sort of let you figure out that on your own. Actually not too hard to find out that you would get radical 6 plus radical 2. And I'll let you verify that on your own if you multiply by the conjugate. All right, so guys, that is it. This concludes our video on the sum and difference formulas for sine, cosine, and tangent. Are they the most commonly used formulas out there? Are you going to be seeing them a lot in your future math classes? Perhaps not so much. However, these things are very, very handy to know and just to have in your back pocket, just in case you do need to pull them out every so often. So if you have any questions or comments, please be sure to reach out to me, guys. Emails, texts, cell phone calls, postcards in the mailbox, rocks through windows, messages written on my windshield, whatever you have to do. Otherwise, until the next video, take it easy, guys.